So like I said, the only real examples of where you'll have simple interest and simple interest in the real world, in adult life, is like buying a car and possibly buying electronics and stuff from JB on finance. But the remainder of interest that you'll encounter in real life is done on a compounding basis. So buying a house, putting money into an interest earning account. So in real life finance and banking, a more complicated form of interest is used called compound interest. Like simple interest, it's still a set percentage, but there's a difference. There are compounding periods where the interest is calculated and added to the principal each time. And we're going to illustrate the... Would you two like to present this? However, there's compounding periods where the interest is calculated and added to the principal each period. In simple interest, every year that you earn interest, it flies away. It goes to you. But here, in compound interest, the interest that's earned, it goes onto the principal, right? And then this larger principal, you find the same percentage of that. If that principal is larger, then the interest is going to be slightly larger too, which we'll see in the maths. This means the principal is always increasing and the interest is always increasing. Overall compound interest is calculated with a simple interest formula, but you're repeating it each compound period. So the two examples that I want to do are literally to directly address the Australian curriculum. Year 10 says that you guys need to be able to see the contrast between how simple interest works and compound interest works. So we have two situations here. The simple interest situation is find the final value in interest earned if I did $100 simple interest over 3 years at 5%. Whereas this one, the compound interest one, it's still $100. It's still over 3 years. It's 5%, but the only difference is it's compounding once a year, which simple interest doesn't have. So what does the maths look like for simple interest? The principal for simple interest at the start is going to be 100. And SI is equal to PRT will be SI equals the principal of 100 times by what's 5% as a decimal? 0.05 times by, and we're only doing year 1, so it's 1 year. So 5% of 100 is going to be 5. So SI is going to equal $5. But what I've tried to explain here is that in simple interest, that principal stays the same. This $5 goes to you. It doesn't go back onto the principal. So in year 2, it's still going to be $100. And if the principal in year 2 is still 100, is this maths in the interest box going to be any different? Has anything changed in year 2 if the principal is still $100? No. So SI is still going to be $5. And then in year 3, because it's simple interest, that interest that you earn every year doesn't change. It's still going to be SI is equal to PRT, and the principal was still $100, so SI is still going to be $5. So find the final value. Well, the final value will be, what was your principal? $100 plus how many bits of interest did I earn? I earned 5. I earned another 5, and I earned another 5. What's that in total in interest? 15. Therefore, final value is $115. Interest equals $15. Can you get that first example down, please? Because that's a simple illustration of how simple interest works. Principal remains unchanging. Still a set rate, but the principal does not change over time. A couple of minutes. Toby, leave that alone. Yeah, I'll have to edit that now. Sorry, my bad. It's been a while. I haven't recorded for a long time. Yeah, rusty. I haven't done it for a while. Yeah, question? Look at the data.
Okay, I'm just beginning to see why I'm doing that instead.
Why?
These
Because I wasn't getting smacked with the rules.
as the resistance score on the y-axis, and if you just watch how I did it in Excel on the video, and then do exactly. All right, let's demonstrate compound interest so that you can get onto your practice, and I can go through the tests. So the difference with compound interest, it starts the same, because in the very first year, it's a principal of 100. So SI equals PRT is going to be SI is equal to 100 times by 0.05 times by 1. In the first year, you're going to make $5 of interest. But this is where the difference for compound interest comes. That $5 now does something. It gets added on to the principal. So what's the principal going to be now in year 2? Is it still going to be 100? It's going to be 105. Do you agree that 5% of 105 is going to be more than $5 now? So it compounds, it builds slightly. But remember that after the first year, it's built slightly. But in the third year, it's going to be 5% of that 5% of that 5%. It keeps building. That's why it's called compounding interest. So SI is going to be PRT. SI equals 105 times by 0.05 times by the 1 year. SI will be 105 times by 0.05. $5.25 of interest in the second year. What will the principal be in year 3? Is it still going to be 105? What's it going to be now?
110.25.
Good. So some people forget you earned a little more. It's going to be 110.25. SI equals PRT. SI equals 110.25 times by 0.05 times by 1. 110.25 times 0.05. $5.51. So can you see through this illustration, is the principal constantly growing?
Yes.
Is the amount of interest that you generate constantly growing?
Yes.
That's why it's called compounding interest. So the final value is going to be 100 plus 5 plus $5.25 plus $5.51. 105, $110.25, $115, $115.76, I think. It doesn't seem like much of a difference right now compared to the simple interest, so you're only advantaged by 76 cents. Right? That doesn't seem like much, but is it more than zero difference? And if we, over time, build it up to, say, $100, it'll keep building on itself. Eventually, it gets really fast. It grows in an exponential way. It gets faster over time. Okay? So I'll stop the video there.